Hey, what's going on guys? Welcome back to my series where we're making a game similar to the game The Binding of Isaac. Today we're going to be really stepping it up. We have a new monster that is a mechanical bug enemy, and basically he picks 3 paths in front of him and they're 15 degrees apart. He just chooses one of the 3 paths and he goes to it. This is a lot more involved than all of the other monsters that we made. He's got a visual effect for when he burrows into the ground. He's got a visual effect for when he goes under the ground. He has a visual effect for where he appears at the end. We've drawn this trajectory so you can see where he's going to go. This is obviously not going to be in the final resulting version of this. I'm going to be hiding these game objects. They're just for visibility's sake. Also, if he's too close to an edge, I'm getting bad luck with that, but if he's too close to an edge, he'll pick a path that makes sense. So if you're like this and there's a path that goes off here, he'll go left. I should have seen that coming probably. So also the outline script, so I don't know if you can see this, when he burrows under the ground, he's fully invisible, so the outline script is deleted while he's going under the ground. And this is a lot harder than any of the other enemies that we've made. The entire project is available for download for free in the description of the video, so you're welcome to download it and use whatever you want to, however you want to. And the playable copy of the game is actually available in the description of the video as well, so if you want to download the playable copy of the game, you're welcome to do that. And if you guys are enjoying my series, make sure you like my video and subscribe to my channel. And yeah. Alright, so before we get started with the code, I just want to show you. So this is the bug that I modeled in Blender. If you want to learn how to model in Blender, I recommend Ryan King Art. That's kind of how I learned. I mean, I did a bunch of things. I also did a robot course that I paid for, and that was pretty good too. And I learned a lot from it. This is not really a Blender tutorial series. So if you want to learn Blender, then you should go find a channel that has step-by-step detailed videos on how to do this. But so anyway, so this guy, he's just 3 spheres. So, I have everything hidden, hang on. He's just basically 3 UV spheres, and then I just extruded parts of him away from it. Everything's very boxy. I guess the hardest part would be maybe his pincers. The animation obviously is the hardest part. I used the meta rig to rig it, so it's just an add-on in Blender. So if you go to armature, you can get animals, and I think I used the cat or the wolf or something, I can't remember. Anyway, like I said, this is not really a tutorial series on how to do this. I also painted this as well, so you can see each of these little tiles is painted in kind of a gradient, a circular gradient kind of way, but it's actually painted by hand, not by using the actual gradient tool. I think that looks pretty cool. You can see it in the game a little bit. Oh, I killed him already. Hang on, let's get out of this. So in the game, it's not really noticeable because it's a top-down game and you lose a lot of detail in Unity. But you can see it kind of makes it look gemstone-y on his arms or whatever. Yeah, I think it looks pretty cool. So anyway, this is just going to be the code for how to make him do this stuff, and I'll show you how to make the visual effects as well. It's not going to be how to model this. You have to go follow other videos on how to do modeling. All right, so before we get to the code, there's just the same components that we used on all of the other monsters are pretty much the same for this one. So we've got an animator where we've dragged in the I put this on the other screen. That's right. If you click on the model, when you drag it in, you can go to the rig and you can create an avatar from the model and click apply. I've already done it, so that's why it's not showing the option. So inside of this, you can see there's the animator, and so then we have the controller for this. So there's 2 states. There's burrowing and nothing. Ideally, there could be an idle animation where it kind of moves around a little bit or does something. It doesn't really matter. I think it looks pretty cool without that. But so we've got 2 animations. One of them is just a default blank state, and then the other one is the burrowing thing. There's an exit for this that will automatically transition into doing nothing after this. The burrowing animation is done. We've set the exit time to 1, and it's just the default stuff that we've done for all the other stuff. But if you just tuned in now and you haven't done any of my other videos, then you don't have to. It's just that. I've added a nav mesh agent. These are the settings. It's relatively fast. 80 is super duper fast. So the nav mesh agent will make it so that if there's nav mesh obstacles, or if there's a hole on the ground, he'll go around the hole. So some of my rooms aren't there's holes in a lot of my rooms. So by using the nav mesh agent, you can he'll go around the holes and stuff like that as well. You could do this just using the transform, I guess, and move it with the rigid body, but I'm using the nav mesh for everything else, so it makes sense to do it this way. There's a rigid body, obviously. Everything's frozen on the rigid body. We're not moving it with the rigid body. This is just so he can get hit by attacks. There's just a box collider that's like this. So when he does the animation and he moves forward, this box collider actually stays on the ground. So that's important to note because it will hit the person. Like that's how he like just collides with the player. The when he does the animation, the actual bug itself goes underground, but the box collider doesn't actually follow that animation. There's a setting for that, but we're not going to cover that. The outline script, this is something from the Unity Asset Store. This makes everything look really cool. So definitely a really good asset to have. Basically, you just bring it into your game. You could drag this onto any of your objects, and it adds a cool little outline on your character. Oh, I got one of the... this room is not supposed to be active. So you can see, like, when the game starts, he's got this black outline, and oh, he's not above the ground. Maybe I just move him upwards. But he's got this cool... Oh, it's because he's doing the animation. He's got like this cool black outline, and that when you're playing like a stylized game, it like really adds a lot to the way like it looks. So like you can see him better, and you can also see him through the walls. It makes it easier. So like if you enter a room, it's easier to see like how many enemies there are and that kind of thing, if you can see that kind of thing. So let me get out of this again. So that's pretty much all of like the components that we have in it, and I'm going to show you the script. All right, so inside of the script, this script is inheriting from enemy. So we made a bunch of enemies already, and so a lot of like the methods and these properties are shared. Like the health, all enemies have health, right? So we're using a base class to save a lot of like the settings. So let's go into the enemy. And so before we cover enemy is inheriting from the enemy damage script. This is a script that when you hit the enemy, he flashes pink or red. He flashes red and then he flashes back. So he doesn't instantly become red and then instantly go back. He lerps. He uses linear interpolation to like go between the color that he already is to red, and then from red back to the original color. This is a pretty complicated script. I did a whole video on this, so I'm not going to cover this in detail, but it is inside of this, and it will do it for all of the sub-objects. So inside of your character, you might have like, in this one, I don't think I have too many, but you might have like 100 different objects inside of here. It will do it for all of the objects that have the property of underscore color attached to it. So if you use a shader to apply the color to him, as long as you're using underscore color as the variable inside of the shader, it will flash him red. And it's pretty sweet. So anyway, let's go back to enemy now. So enemy, the enemy just has like all of the default things that an enemy would have. So like his health, his max health, whether he's a boss or not, what the boss name is. So like inside of that boss health bar, there's like a name on it. This is pretty much all stuff to do with the boss. So inside of the start method, it gets the rigid body, and then it also calls base.start. So because there's multiple start methods, we're overriding the start method of the base class. So if you want the start method of the, it'd be nice if they just put this side by side. Hang on, let me just do this. So if you want this start method to happen, then you have to call it manually because we're overriding the start method. So only this start method will happen unless you call base.start. The base class is, the class that you're inheriting from. So we also do that in actual mechanical bug enemy script as well. So we're calling base.start here, which calls base.start here, which calls base.start in... Oh, sorry, this one doesn't have base.start, but it calls the start method from this one. So aside from that, that's for the health bar if it's a boss only. And then there's the collision code right here. So if it hits the stickman... this is my protagonist name, so you would have to obviously copy the one. It adds an impact on a game object. Because my character is using a character controller, he's not using a rigid body, so you can't apply force the way that you normally would. Also, if you do add a rigid body to your character and you try to apply force to your character, it won't work because he has a character controller that locks onto the ground. So in order to push him back, you would have to disable the character controller and then push him back with the rigid body and then re-enable it. So instead of doing that, we have this add impact on game object script. This is something, again, I covered this in a previous video, but basically there's a static class that it uses the character controller to actually move the character back. So yeah, so we're getting the character controller here. We're using move. We're moving, so it depends if it has a character controller or not. we're moving it using the character controller. That way it will actually move, because if you don't do that, if you try to use a rigid body, it won't actually do anything. And then we're taking damage using the heart script. Again, this is something we made in a previous video. So if you've been following the series, you should have all of these scripts as part of your game already. But basically, inside of our take damage script, we're checking if the player's invincible. When he gets hit, he's temporarily invincible for a certain period of time. All of the code involving drawing the hearts, flashing the screen red, pushing the character back, all that stuff, the armor, because there's armor as a statistic in my game, all of that stuff is handled by this script. Again, it's in a different video at like the very beginning of the series. So, and then if it's a boss and he dies, this spawns like the items and the devil room and the next level portal and that kind of stuff. So that's pretty much it for the enemy script. And so then now this is the custom script for this specific monster. Okay, so the best part to start with here is the start method. So we're getting the nav mesh agent and the animator, and then we're starting a coroutine called burrow. So burrow is basically what he's doing. So every so often he'll pick he'll draw 3 paths on the ground. He'll pick one of the 3 paths, and then he'll go down the path, and it's random. So this is where it kind of starts. So we wait a second, then we play the burrow animation. So this is the only animation that's attached to him. So this is the burrow animation. So he raises up and he just like kind of moves his things around or whatever, and he dives into the ground, and then he comes back up afterwards with like this like roaring kind of like thing or whatever. This should be faster. Hang on, let me just change the frames. It just might be lagging because I have like here we go. Okay, there we go. So he like goes underground and then comes back up. So that's the burrow animation. So he plays the burrow animation, and we start this digging visual effect while he's playing the burrow animation. So let's go in and check out the digging visual effect. So let's just put that on the ground here. And so this is the digging visual effect. And let's move it over. Actually, let's unpack it before we oh, it's not packed. Okay, let's just go move it over here. So the digging visual effect, we're just using the rock generator for this. So inside of Blender, if you go to edit preferences, we cover this in many videos, but there's something called extra mesh objects. And inside of extra mesh objects, there is a rock generator. So if you press Shift A, you can go mesh extras rock generator, and make sure that the rock is a cool looking rock. And because we're using the visual effect graph, this is drawn with the video card, so it's pretty good performance. You could, when you spawn the rock, if it's too laggy for you, or you want something like a little bit more performant, when you generate it on the left here, you would just change the detail viewport and the render to 1. That way there's less geometry. And then you could also go into the modifiers, actually just convert it to a mesh, and then you can press tab and see how many vertices it has. So that's pretty low poly for the rock. If you wanted, you could decimate this as well to make it even less if you really wanted to. So, oh, that goes all the way down to 0. Oh, it's because it's in, there we go, 73, okay. So like if you want, you could make it even less poly until it just barely looks like a rock. And because it's not really, like the detail of it is not really that important. I like the way that this looks. I also applied a shader on this as well. So let me just open up this visual effect. So this is pretty much the standard like visual effect. We're just spawning bursts of rocks. So it's 10 rocks every 0.3 seconds. So they don't all come out like normal. Like the default is actually to have a constant spawn rate where like 1 at a time appears. But instead of 1 at a time appearing, 10 appear. So it kind of like all comes out at the same time. Which makes it look pretty cool. So then the capacity is pretty high. We're setting them into a circle because they're going around the little dude or whatever. Like they're going around the scorpion dude. You don't want them spawning right on top of him. So if you actually look at this really closely, they're spawning in a circle at the bottom right here. This is a circle. I keep clicking on the wrong thing. So we've rotated the circle 90 degrees. The radius is 4, which is just big enough to be like around him. We've set the size to 0.5. We're setting the velocity so that they're going outwards, but the Y is higher. So because we want them to go upwards, and we don't want negative Y because we don't want them to going downwards at all. We only want them going upwards away from they shouldn't be going into the ground, right? The angle is going to be, negative 90 degrees because the rock is kind of like, yeah, they all start at the same. Well, this could maybe be a random. I don't know. Actually, let's turn random on for this, and we'll do this with these. Yeah. Anyway, it doesn't matter. So you can't really tell the difference. So then we're adding angle random per component. Okay, so we are adding angle random already. Let's just undo everything we just did. Hang on. Oops. Save this. Make sure it still looks normal. Yeah, so it only randoms on like the y-axis. That's fine, whatever. You could random or not. It doesn't matter. The lifetime is just 1 to 2. In the update particle, we're adding angle over time. Make sure you add very small numbers when you do this because this rotates the rocks. So like as they're coming up, you can see that they're rotating. So like they don't stay facing the same angle. So then we've got this metal shader graph. This is actually not a metal shader graph. This is a cartoon shader graph. We did an entire video on how to make this cartoon shader graph, but there is one on YouTube that's way more straight to the point. The only difference between the one that I have and the one that's on YouTube, where they have like a very straight to the point video on how to do it, which I'll link in the description, is I've added a rotation. So you can rotate where the cartoon shader is being drawn. It's not based on like the default light. So each object can look different. So if like you zoom in on this, these rocks are using the shader and like the direction is straight down on these rocks. But on mine, I have an option of rotating it because some of my objects look better with the rotation being different. And I also have this reflection shader. This is not part of, I'm not using this in the rocks or whatever, but this is for the chests in my game. So I have like, they have cartoon, but they also have like a metallic effect because the one that is available online is non-lit. So it doesn't have reflection. So I manually added the reflections back to it. So I'll link you to the cartoon shader video. It really adds a lot. Like if you look at these, they have like different like layers, and you have to use a shader to actually draw the material onto the thing. If you don't have this shader option, this is actually an experimental operator and block. So if you go into, I think preferences or project settings, if you go to, visual effects here, there's an option for experimental operators and blocks. If you don't turn this on, you won't have a shader graph option. Also inside of your shader graph, under the graph settings at the bottom, you have to enable supports VFX graph. If you don't enable this, the shader won't show up as an option. But this really adds like a lot to the way that it looks. You can't really see it too much from top down, but if you look at the rocks, they look more rocky because of the cartoon shader graph. Yeah, so that's it for the digging effect. Let's get rid of that one for right now. And so then there's the burrowing effect, which was a little bit harder than that one. So burrow. So let's again move it a little bit to the left, and we'll get a scene view here. Okay, so you can see like from the top view, you can't really see it as much, but these are going up at different randoms. So inside of Blender to do this, I just made 3 rocks using the same thing that I did before. So go to mesh, extras, the rock generator, just make 3 rocks instead of just 1. And again, make sure the details and the render viewport are set at nothing. Let's go ahead and hide the bug thing. And, oh, I hid my rocks. Okay. Oh, they're in the same collection. Whoops. Just hide the bug. Okay. So these 3, so we'll go into edit mode and we will select each of them. So you can press L to select them, like the actual rock itself. And then I just did this. And then if you get a side view like this, you can take the points and move it up like this, scale them towards the center. So instead of doing individual origins, you could do the center and you could scale them together like this, so they're close together. And the base of this needs to be so that it's like this more. So you just want to make the base like a flatter. I'm not gonna spend too much time on this. And then when you're done all this, you'll take all these and convert them to a mesh. And then you'll use the weld modifier to weld the vertices together so that these objects are connected. And, sorry, they're not joined together. So you have to join them first, Control J. And then after you've joined them, you can use the weld modifier to remove any imperfections or whatever. And so you just get a rock like this. And, you might need to go into edit mode and like merge some of the vertices together to make it look a little bit better, but it ends up looking really cool. You want to make sure that it's centered though. So this one's not centered. So if it's not centered for you, you could use the proportional editing tool to center it. And then you could, again, just use this to move it up a little bit like this. And then maybe this part can come down and this can come up like this so that the bottom is a little bit more flat. And if you really wanted, you could flatten the actual bottom by scaling it on the Z-axis, because we want it to be kind of flush with the ground. So if we press Alt-Z, you can get a see-through view, and you could press SZ0 to flatten it on the bottom so that it's actually flat. And then so when this comes up from the ground, we'll be expanding the scale on the Y-axis to make it come up. So like when we actually spawn this to attack or whatever, it will scale it on the Z-axis. It's Z in Blender, but it's Y in Unity. So it will be scaled like this. And you also want to make sure that the origin is at the very bottom. So if you right click this, you can set the origin to the 3D cursor. And you just want to make sure that this is like this and like this. So by setting the origin to the bottom, when you scale it, it will scale from the origin. So scaling on the Z axis, it's not doing it right now because we didn't set it to individual origins. Anyway, it works better in Unity, but you just want to make sure that the origin is set to the bottom and you apply the transforms and stuff. But this is how I made like this spike thing. So then I'll show you the visual effect as well. So this is happening very, very fast. So let's see, where's my visual effect here? So we've got 10 per second. So the capacity is 500. We're setting the position. Okay, so because this is following the bug, we don't want it to stay under the bug. We want it to be spawned in world space. So in the top right corner, you can see world written here. If you click this, it changes from local to world. So because we've set this in world space, then the position will be wrong. It will spawn in the very center of the thing. So then we have to set the position to the local space. So this is where the bug is, right? The local space. And then the Y can be 0 because we want it to be flat with the ground. And so we're just getting the position of where the object is, which is the bug. So this is where the bug is, and we're setting this in a local position. And we're setting the size to 1. We're setting the scale to be between 1 and 5. So that's again, the height of like the spike. We're setting it doesn't really need to move. So this is not really, it just makes it move a little tiny bit. So it doesn't really matter. You could turn this off if you want to. The angle is going to be -90. So this makes it face upwards. You could also just set, when you export it, you could export it using Y forward instead of Z forward. And then you don't have to do this part of it if you don't want to. The angle is going to be between 0 and 360 only on the Y angle. So, that's like this, right? And then the lifetime is very, very short. So 0.3 to 0.5 seconds. So as he's going under the ground, these are just disappearing. So they're appearing very quickly and disappearing. We're using the quote unquote metal shader graph, which is actually the cartoon shader graph, as the lit mesh. And again, you're putting the mesh as this. So this is like the spike that I just showed you how to make in Blender. And so then we're multiplying the size over life. This is the thing that makes it go up and then come down. So let me just zoom out on this. So it's going from 0 all the way to 3 and then shrinking a little bit. So it goes very, very small. So 0 is 0. So it's non-existent. Goes all the way to 3. So like spiking up really hard and then down. And because we've already set the scale here, it will scale based on this. So like, even though it's getting bigger, the majority of the gain will come from the height of it expanding rather than the whole thing just becoming bigger, like width wise. And so let's delete that. And then we have the rock explosion. So this is what happens when he comes out of the ground. So let's move that over a little bit and we'll click on this. This is the same thing as the first one, but instead of having a periodic burst, which is like every 10 particles coming out every second or whatever it was, we're doing a single burst. which 100 of these rocks come out all at the same time. We're still setting it to an arc circle the same way. The radius is a little bit smaller. Multiplying the position as the output of this makes it go away from the center. So if you have a circle like this, 'cause these are, this is what we're doing right here. Set the position arc circle. If you get the position, it's the position from the center. So get position will get the position of the particle right here. For example, these are the particles. And so then we're multiplying that by 8. So it's going from the start position of 0 away from the center. So these particles, will go this way away from the center to make it like a circular explosion. And then on the y-axis, it's going to be between 8 and 45. So they'll go upwards by 45, which is a lot, but they'll also go outwards based on this circle. And so this is how far away from the center that they'll fly away from it. So the higher this number is, the bigger the explosion will be. And you don't want to make it too big because there could be multiple of these in the game. And so you can see that it does kind of go away from the center, but it's mostly going upwards. Like it's going up more than it is going there. And let me just get back to this. The lifetime again is very small. So maximum of 1 second. We're rotating this as they're coming out. So this is the rotation over the lifetime of the particle. And then again, we're setting this same cartoon shader graph as the first one. And we're multiplying the size over life to start at the full size and go down to 0. It's super important that you change the composition of this to multiply, because if you, the default for over life is to overwrite the size. And so you want the size to be multiplied because we set the size to 3 up here. So if you don't do that, then they'll be super duper small. So those are the 3 effects that are happening. And so now I'm going to go through the actual like logic code. All right, so now that we've covered all the effects, this is how it's working. So we play this burrow animation, which I showed you in Blender. We play the digging visual effect at the same time that we're playing this animation. So that's what makes like the rocks come up. And that was the first visual effect I showed you. After 2 seconds of him digging, then he stops digging. It hides the outline. So because he's going under the ground, the outline shows through the ground. So I get the renderer for this, and then I replace the outline material that gets added with this transparent material. I draw the trajectory. So this is the hard part, I guess. So it's basically, there's 3 lists of vector 3s that we're using to like determine where he's going to go. So the first thing we're doing is we're getting rid of all the points. So the points are saved from the previous one. This is only for drawing this on the screen. This is not for the actual thing. We're using vectors for that. We're probably going to get rid of this altogether out of the code because we don't need these game objects at all, or we're going to make it a variable or something like that. Well, I'll probably do that later. So we're destroying all of these little circles before we do it again, and then we're clearing the points from this list because we're saving all the points in a list so that we can easily get rid of them. So these are like the variables for the settings. So the spacing is how far apart the points are. The obstacle radius is how close any obstacle can be to one of the points with the so this is like the radius around the points that it's checking if there's an obstacle there. And then the angle offset is the 15 degrees, like it's 15 degrees between each of the possible paths. Like it's the angle between like the different paths. So then we're creating a layer mask where these are the green listed layers where it's acceptable for the bug to go. So the floor, obviously it's okay for him to go to any spot on the floor. If we're checking a radius around each of the points, if it hits the floor, that's okay. If it hits an attack, that's okay. And if it hits a player, that's okay. The whole point of him is to attack the player. So yeah, so like these are the accepted layers, and then we're just creating this into a layer mask. I'm not going to explain the syntax. It's disgusting. I don't know why they made it like that. Then we're storing an array of paths. So there's 3 different lists of vectors that these are the possible points where the bug will go to. So it's creating 3 separate paths, and each of the paths is a list of vectors. We're doing the same thing with the game objects. Again, this is probably going to get deleted because we're just using this to visualize where the potential paths of the bug. It was only for debugging purposes, but we're probably going to end up getting rid of this. But this is the real code here where we're getting 3 separate lists of vectors. These are the potential positions that the bug can go to. Okay, so these are the directions. So we've got the forward direction, the left direction, and the right direction. The reason the forward direction is negative transform.forward is because I put when I exported the bug from Blender, the bug is facing the wrong direction in Blender. He's facing completely backwards. So instead of fixing it in Blender, which I probably should have done, I just have the negative forward. So if you're not using the bug, if you're using like a different object or something like that, which I don't know why you would be, it should be transform.forward in most cases. I just have my thing modeled in the wrong direction. So don't judge me. So then we have the left direction and the right direction. So this is the middle direction. And then the left direction is 15 degrees to the left of the forward direction, and then this one is 15 degrees to the right of the forward direction, and then we're saving the directions into an array of directions. We're creating a glow material. So in the paths, one of the paths, the one that's selected, the very last point, that's the point that he's actually going to. We're going to make that one have an emission. Again, this is going to get deleted because this is part of the it's like I've just created these game objects to debug where the bug is going and to make sure it's working properly. So this is just a material to show you which point is getting selected. But again, we're not going to be saving this. This is going to get deleted probably. All right, so this is where the code gets a little bit confusing. So we have 3 paths that we're going down. So this is just the index of the path. So there's 0, 1, and 2. So 0 is the left, 1 is the middle, 2 is the right. End branch is a variable that I'm using. If the path hits a wall, we don't want to keep checking because we don't want him to go past a wall. So if there's a wall in the way, like if the actual collider has the word wall in it, we're going to end the branch so that way he doesn't try to keep going off forever. And by putting this here, we can break out of this so that it doesn't keep generating a path past the wall. Even though like it's because if you go far enough past the wall, eventually the collider will pass, right? So like let's say he hits the wall here. Well, if it keeps going past here, these will pass because there's nothing there. So we're only checking for obstacles. We're not really checking for anything else. And if it doesn't hit anything, they'll succeed and then he'll try to go out of the bounds. It won't work because the navmesh agent is smart enough to only go on the navmesh, but still you don't want to have him try that. You should just have him, he should only be going inside of the boundaries of the level. And there might be some weird circumstances, like let's say there's a wall here and then like maybe it goes past like this, then he won't be able to go past the wall, but then we'll get to that when we get to it. We could solve that potentially by not having the word wall in like the thing or whatever. But anyway, so we're getting so for 20 points, we're drawing 20 points on the ground that he can go to. We're spacing them out. So we have the position of the bug where he is. We're adding the directions at the path index multiplied by the spacing and I. So the first point would be like right in front of him, and then the spacing I is going up, right? So I was 0, then 1, then 2, all the way to 19. So it will become further and further away from his start location, and it's being multiplied by the direction. So it will go in the direction that it's supposed to be facing. Then we're checking the each obstacle to see if it's near an obstacle or not. And so if it's near an obstacle, then we're going to set the color of the point to be red. And if it's not near an obstacle, then we're going to set the point to be green. Now, so we're adding the point to the actual screen so we can see it. This is the game object point. But if it's not, like if it's not green, like if it's not in the else clause here, we're not adding it to the actual path points. So this is the list of vectors that the character is actually going towards. But if it's not, like if it hits the obstacle, or if it sample positions, if it's not on the nav mesh, then it will be red and it will not get added to the list of potential points. So this only adds points to the list of vectors that are viable. So we're checking for collisions here. And then again, this is checking for the wall. This is creating the actual circle. We're just using create primitive because it's a sphere that we're using. We're setting the sphere to be a little bit taller than it is wide. And then we're setting the position, obviously, to be the point position that we're putting that at. This is where we set the color, and then we're adding it to the list of game objects here. So then we're randoming a path. So there's 3 paths. There's the left, the middle, and the right. So we're just randoming a number between 0 and 2. The top number is exclusive. So random range is actually 0 to 1 less than this number, unless you put a decimal and then it's a float and it changes it. So that'll be 1 decimal less than that. So if we select a path that doesn't have any points at all, then we're going to check if any of the paths have any points. So, for example, let's say your bug is right against the wall and he's facing, and your character is like right here and he's like facing this way. It's a potential that the random will select the path that goes this way. But if there's no points in that path, in the selected path, which is random, then it will try to see if any of the paths from right to left have any points in them. So the reason we're starting at the right is because if the very left path we want it to go left to right, so we're going backwards, because if this has points, this will overwrite the selected path. Each one of these overwrites the selected path variable, and so we want the very left path to actually be first, so it's a left to right type of algorithm. If the selected path count is 0 still, so like, let's say all 3 of these don't have any points, maybe he's stuck in the wall or something, then we're going to set the target position to be where where the enemy is. So if none of these have any points, we don't want him to try to, because dot last is not going to work unless there's an actual, if this array doesn't have any points on it, then dot last is not valid, and so it will fail. So we just want to set the target position to be the transform position. And then so right at the end here, this is where we set the glowing material to the target sphere. So this will, we're taking the selected path and we're getting the last game object in the selected path, and we're just setting the material to be the glow material. This is where the bug is actually going to go towards. So this is what gives you like the glowing thing or whatever. This can be deleted because we're not using a trigger, so that's not related to anything. So let's go back to the top here. So that's how we're drawing this trajectory. And it's not just drawing the trajectory, it's actually getting the trajectory as well so that we can use it. Then we're setting locked to be true. So inside of the fixed update, there's 2 possibilities. There's if locked is not true, and there's if locked is true. So if locked is not true, then we're going to face the direction of the player. So he'll be rotating constantly to face the direction of the player so that he's not just standing there doing nothing. And then in this one, the rotation is actually rotating towards the target position. So we're going to be rotating towards the green dot, like the dot with the emission, the point that we're going to from the draw trajectory. We're going to rotate towards that. And then this one will actually set the destination to this target position. The target position, again, is set inside of this this larger method from draw trajectory. This is set here. So then we're rotating towards this target position, and we're actually setting the destination to that target destination. So if the random is not the transform position, okay. So if he's if there's no points on the thing, the target position will be where he is. So we're setting the update rotation to be false, because if you set the target position, if you're trying to rotate to exactly where the character already is, he might start spinning in a circle like crazy. So this will prevent him from spinning in a circle. So that's what locked does. Locked is what actually makes him start moving. And so then we start playing this spike VFX, which is the visual effect with the spikes coming out of the ground that I showed you. We only do that for 1.2 seconds because this is roughly how long it will take him to get there. After we get there, we stop the spike visual effect and we play the rock burst that comes out of the ground. Here we're restoring the outline. So this is where we put the outline back on the bug character, or we attempt to anyway. And then we wait another second. So he has like time to finish what he's doing. Then we set locked back to false so that he'll start looking at the player again. And then we start the coroutine over again. So that's the entire process of what he's doing. And I think that's everything for the enemy. It's a little bit more complicated than the other enemies we've made. Like I said, the entire project is available for download in the description of the video for free. You're welcome to download it and use whatever you want to in your game. If you guys are enjoying the series, make sure you like my video and subscribe to my channel. And hopefully I'll see you guys in the next one.